Two-sided significance test. Used when you think a claim is bogus. But you don't care if it's greater than or less than. Okay? Here are examples of questions where we have this type of situation. Okay? Let's go back to the examples we did at the beginning of class. Government official claims that the dropout rate for local schools is 25%. We then said we think it's less than that. That's why our alternative hypothesis was that it's going to be less than 0.25. The question will change to, we don't think that's true. I don't care that we think that it's less than. I just don't think it's true. I'm saying the government is wrong. What will change is that this will go from a less than to a does not equal. Okay? Look at the next problem that we did. Jim thinks that the proportion of females in the high school is 40%. You don't like Jim, and you like to pick on Jim, so you just say, Jim, you're wrong. You think Jim is wrong. Okay? You don't care. You're not going to offer up your own opinion. You're just going to pick on Jim, and you're going to say, Jim, you're wrong. Stop talking. This becomes this. All right? And our last one, Luke thinks that it has to be greater than that. Well, Luke just doesn't trust Italians, so Luke thinks it's wrong. Luke is a racist. Luke doesn't care that it's greater than. Luke just thinks it's wrong. Okay? Now, what happens when we have this change here is that when we have our normal curve, when we find our z value, say we have a z of 2, and we find our p value, let's go 2.5, because we already did that. Well, we are going to not only find this here, but we will also find the probability that we will have something as far away below our mean. So we will have our 2.5, we'll have our mean, but we'll also have to include this probability down here if we are below that value. Okay? That way, instead of the z being far enough away on one side, the z has to be far enough away on both sides. Okay? If that makes sense. Because we could have values that are less than or values that are greater than that will prove that our claim is incorrect. Okay? How do I take this value, this p-value here, which is 0.006, which we found, and quickly and easily add in this percentage that I need? If this is 0.006, what is this area down here less than -2.5? It's also 0.000 or 006. So together, we just have to double 0.006, and I get what is considered my two-sided p-value. Okay? All we have to do for this lesson is everything that we've already done. we're going to find our z-value. Don't listen to whatever this says. Just find the z-value. We're going to find the p-value. Get rid of this. Get rid of this. Do everything that you've been doing because you guys are doing great. Find z. Find p. Double the p. And that is the p-value that you are going to use to see whether or not our z-value is far enough away from our mean to say that our claim is false. Okay? So let's go back to our problems that we did and see if that would change anything. Typically, it doesn't. Okay? But we have the government official, and we don't think that's true. We would do everything the same. The only thing that I would change is this. The p-value I would double. And I get 0.0048. Well, guess what? That's still less than 0.01, so I would still reject. We don't care that it's greater than. We don't care that it's less than. We just find the p-value and then double it, and we'll get our new two-sided p-value and say, yep, it's still far enough away. For the next one, everything stays the same, but I would double my p-value. Well, my p-value times 2 would be close to 0.4, probably 0.39 something. Well, guess what? That p-value is still larger than my significance level of that. So I would still say my claim might be true. I'm not going to reject. And I can still see that by looking at my z-value here, 0.845 is not far away from our claim. The further we are from the claim, the more likely that the claim is true. Okay? So everything stays the same. But let's go down here. And we have a significance level of 0.05. Sure. Well, let's go 0.01. No, it doesn't work. 0.025. Close. 0.02. Perfect. Okay. If I went to a significance level of 0.02 and I get a p-value of 0.014, well, this is telling me that this is far enough away because it is less than 0.02 in this situation. But if I change it to just, I don't think it's true, then I have to take this p-value and double it. I get 0.028. Well, that turns out is greater than 0.02, and all of a sudden I need to now say it is not far enough away. And I would fail to reject. Okay? So everything else is the same. Everything that we've been doing is the same. You just need to double your p-value. Okay? Let's do an example. According to M&Ms, 20% of all plain M&Ms are orange. You don't think that's true. You think either there's a lot of orange M&Ms in a bag or there's no orange M&Ms in a bag. Okay? You don't care which way it is. You just don't think that's true. Here we go. Our null hypothesis is the M&M claim that my mean is 0.2. My alternative hypothesis is me saying, I don't think that's true. Let's actually figure this out. We have time. Ms. Adams, I need you to count up the M&Ms and the orange M&Ms from this bag.
Can I eat them?
No. Miss Mann, do the same thing for this side.
So count all of them up and then separately count them.
Yes. Count all of them up. I need to figure out how many there are and how many orange ones there are. We need a large enough sample size, people.
I know.
Put your phones away.
0.8 miles to what's off one.
That's not true.
I just looked it up.
All right. Our sample. Miss Adams, what did you find?
I got
10 out of 54? 54 M&Ms in the bag. What did you get, Miss Mann?
I got 5 out of 57.
5 out of 57. Okay.
That does not look good.
So that is 15 out of 111. Okay. Boom. There's our sample data. Our P hat or our X bar is, what's 15 divided by 111? What? Can we stop worrying about calories? You guys burn calories just by sitting. What is it? What's 15 divided by 111? For 135. Okay. All right. M&M's. With your silly claim of 20% being orange. People don't like orange. People like the blue ones, I guess. We think it's wrong. Now, I would have suspected it was actually more than that, but it looks like it's less than that. But I don't care. I just think M&M is full of it. All right? Let's figure out what the standard deviation is for my claim. Go. 0.2 times 1 minus 0.2 divided by sample size 111. How about I get an M&M after this? But I've eaten 8. So, wait. 9, 10, 11. All right, now there's 100 M&Ms. All right. What do we get for the standard deviation? 0.037, right? Now, the 11's got to be in the standard, in the square root. So, yep. Well, that needs to be in parentheses too. I would just do everything first and then take the square root of the answer. So 0.2 times 1 minus 0.2 first. No, well, yeah, 1 minus 0.2. What do I get? 0.0379. Right around that, right? Some extra values. What do we get for the z value? 0.135 minus 0.2 divided by the 0.0379. 1.7123. Negative 1.7123. Okay. Is that what we got? Come on, do the calculations on your calculator.
Okay.
Did we get it? Yes? We got that? Come on, we've done this so many times.
I might have done it wrong.
I don't want to have to do this in my calculator.
Yeah.
Okay, we'll just leave it as that. We'll just round for this example. Okay, good. Now, what do we get for our p-value? 0.04377. Oh, man. Now, if we had a significance level of 0.05, and if this was a one-sided test, you would say that this value is confirming that this is far enough away to reject M&M's claim. However, what do you need to do now that we have this two-sided test? We got to double it. So our new p-value for our two-sided test ends up being 0.0 what? 8754. This is larger than this, which means that this is not far enough away for me to tell M&Ms that they're full of it. Unfortunately, we cannot reject M&M's claim. .05 I just threw there. The .08 is bigger than the .05, so this is too close, exactly. Okay, let's go to the back. Thank you. All right. The director of advertising sales for a local radio station claims that 35% of the listeners will remember the name of the product advertised at his station. You think that person stinks and he's wrong. You don't care whether it's lower or higher. You just think it's wrong. Sample of 100 listeners is taken and 43 recall the product name. Test this claim at a significance level of 0.05. Ready, set, go. This is totally far enough away. Let's find out. 0.43 minus 0.35 divided by that 0.047 number is 1. It's not that far away. 1.677. Not that far away. Store that as X. Second dister. Normal CDF. That value to 10 gives me 0.0467. Oh my goodness. Once again, this appears to be less than 0.05. However, that's for a one-sided test. We have to multiply this by 2 to get to a two-sided test. And my double p-value is now 0.09. So the advertising sales director's claim could be true. That z-value is not far enough away. All right, everybody gets 2 M&Ms. I get the rest. This stuff down here, don't pay attention to the stuff on the bottom of these, okay? Stuff below this, don't pay attention to that.